Assalamu alaikum. Welcome to lecture number 19 of Software Design and Architecture. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture, we discussed different dimensions of software architecture where we see how different perspectives of software architecture for different stakeholders like end users, customers, developers, architect and tester as well. And we see multiple perspectives are required for multiple views, and then we see architecture view model which we call a 4 plus 1 view model. In this 4 plus 1 view model, basically we see how this view model can be utilized by software designer to organize the description of the architecture decisions in different views. And in this 4 plus 1 view model, we see the 4 plus 1 different essential views ranging from logical view, process view, physical view, development view, and the fifth one is the scenario view. And then we see how this software architecture in this 4 plus 1 view is basically is an architecture verification technique for studying and documenting software architecture. This is the brief objective of our last lecture discussion. So let's formally start our today's lecture discussion. So students, what we will discuss in our today's lecture, we see what are the architecture styles or patterns, and we will also see different types or categories of architectural patterns which are currently available. And then from these categories or types of architectural patterns, in this lecture we will briefly cover hierarchical software architecture in more detail with the help of some real world examples as well. So this is the brief objective of our today's lecture discussion. So let's formally start of our today's lecture discussion. So first of all, what are the architectural styles? So basically, architectural styles are also called architectural patterns, which are basically a set of different principles which actually shapes an application. The idea of patterns, you can say, as a way of presenting, sharing and reuse knowledge about software system is now widely used. So basically, architectural patterns were proposed in 1990s under the name architecture styles. So that's why architectural styles are also called architectural patterns. So these architectural styles or architecture patterns are basically defines an abstract framework for a set of families of a system in terms of different patterns of structure organization. So this architecture style or pattern we also discussed in our lecture number 16, but not in more detail. But now in this lecture number 19 we discuss different architecture pattern one by one with more detail. So there are different categories of architecture styles available. So students, one thing you must remember, architectural styles are also known as architectural patterns. So styles or patterns are two interchangeable terms, so you don't need to confuse about these two terms. Architectural styles or architectural patterns are the same things. So there are different, here you can see the different categories of architectural styles. So here are hierarchical software architecture, event based distributed software architecture, data centered oriented architecture, data flow architecture based, component based architecture, and then the interaction oriented software architecture as well. So these are the different categories or types of architectural styles or patterns. These architectural styles or patterns we also discussed in our lecture number 19, but in lecture number 16, but we were not went into more details about these architecture styles or patterns. Now in our coming lectures, all of these architecture styles or patterns will be covered in more detail with the help of some examples. We will also see in what cases or scenarios these architecture patterns can be utilized. So let's start the more detailed discussion about the hierarchical software architecture. Now, all of these architectural styles or patterns will be covered one by one in our coming lectures. So, first of all is hierarchical software architecture. So, students, my question to you is, before I start hierarchical software architecture, so before I start formal discussion towards the hierarchical software architecture, you are well aware about hierarchical style, as you must know about the key components of any architecture style or pattern. किसी भी architecture style और pattern के जो basic components हैं, you must be well aware about that. These any architecture style or component actually summarizes of elements, components, connectors, constraints, and their attributes. All of these key components of any architecture styles are already have been covered in lecture number 16. Now let's start about the discussion hierarchical software architecture. So basically, hierarchical software architecture is characterized by viewing the entire system as a hierarchy. So basically, जो सॉफ्टवेयर सिस्टम है उसको डिकम्पोज किया जाता है डिफरेंट लॉजिकल सब सिस्टम्स के अंदर, डिफरेंट लेवल्स ऑफ हिरारिकी के अंदर. सो देन जो हमारे देन दीज मॉड्यूल्स, जो ये मॉड्यूल्स हैं इस बेसिकली दीज आर कनेक्टेड बाय एक्सप्लिसिट और इम्प्लिसिट मेथड इन्वोकेशंस एज वेल. सो स्टूडेंट्स, these method of hierarchical styles are basically, you can say that in these hierarchical style methods or hierarchical explicit or implicit method invocations are basically we organize the system into layers with related functionality which is basically associated with each layer. If you see in this last diagram, a layer provides services to the layer above to its so lowest level layer represents core services that are likely to be used throughout the system. So, so students, we can say that the software system is actually decomposed into different subsystems at different levels in the hierarchy. Then these modules at different levels are connected by their corresponding invocations method, which can be explicit or explicit as well. In other words, a lower level module provides services to its adjacent upper level modules, which actually invokes the method to procedures in lower level. For example, in procedural language, the function and procedure may be organized in a header file or in a library. In order to make use of services, an upper level module must call the function procedure from these files or from library as well. So if we took the example from an object orientation implementation of this architectural style, these services may be organized in a package of class. Like this package is then imported by the upper level modules to obtain the needed services by making calls to the corresponding class operations as well. So these hierarchical styles are normally utilized by the software system softwares which are typically designed using the hierarchical architecture style. For example, system software is usually built with the help of these architecture styles. Examples include like Microsoft.NET, Unix-based operating system, transmission control protocol, or internet protocol. All of these are different system softwares which are actually built with the help of hierarchical architecture styles as well. So one thing these have in a common is that services at lower levels provide more specific functionality down to fundamental utility services, such as we can say that input output services, different transactions, scheduling, and security services. While if we see in the next slide, while at the middle level layers we are more in these middle level layers in any application, like it provide more domain dependent functions like business or logical processes. If we more focus into upper level layers, which actually provides the abstract functionality uh, from the user interfaces like CLI based, which we call the command line interfaces or interpreters, graphical user interface, shell programming facilities, etc. So each layer provides services to immediate upper layer. Any changes to a specific layer may affect only its adjacent upper layer. अगर हम किसी भी लेयर के अंदर कोई भी चेंजिंग करेंगे तो जस्ट वो उसकी adjacent जो upper layer है उसी में ही affect करेगी, but only when its interface is changed. So otherwise you can say that there are no ripple effects of changes exist as well. So it's about the hierarchical style. So in hierarchical style we actually have a layered architecture. सो व्हाट इज़ लेयर्ड आर्किटेक्चर? सो लेयर्ड आर्किटेक्चर जो है ऑर्गेनाइज्ड करता है लेयर्स को हिरार्की के अंदर, जिसके अंदर हर लेयर हमें सर्विसेज प्रोवाइड कर रही होती है अपनी अबव लेयर को, और वो जो सर्व करता है एज अ क्लाइंट को बिलो लेयर्स के ऊपर. सो देन वी कैन से डैट these layered architecture organize the system into layers with related functionality associated with each layer. So a layer provides services to the layer above to each to the lowest level layer, which actually represent core services that are likely to be used throughout the system as well. So in what scenarios we normally utilize this layered architecture? We normally utilized this kind of layer architecture where we actually जहाँ पर हम ये जो हम लेड आर्किटेक्चर है मोस्टली कहाँ पर यूटिलाइज करते हैं, जब हमने किसी कोई न्यू फंक्शनैलिटीज़ को किसी एग्जिस्टिंग सिस्टम के टॉप पे हमने इम्प्लीमेंट करना हो, लाइक व्हेन द डेवलपमेंट इज स्प्रेड अक्रॉस सेवरल टीम्स in which you can say that each team is responsibility for a layer functionality. So we also use this layered architecture to achieve multi-level security. So secure, you can say that security is the main concern of this layered architecture. So let's discuss a generic layered architecture to get more better idea about this layered based architecture. Actually in this figure you can see that a layered architecture is basically have four layers. The lowest layer include system support software like operating system, databases. Typically, database and operating system support are usually contained in this layer. So the next layer is the application layer that includes the components concerned with the application functionality and that actually utility components that are used by other application component. If we focus on the third layer, which is actually concerned with the user interface management and providing user authentication and authorization, with the top layer providing user interface facilities to the user. So of course the number of layer is arbitrary, so any of the layer in this figure can be split into two or more layers as well. So this is the layered architecture of a it, you can say that this is a generic layered architecture which have a arbitrary number of layers. So any of layers in this figure can be split into two or more layers as well. So let's discuss the more practical example of this layered architecture. So I took the library system example. So this for this library system you can see that how this layered architecture pattern can be applied to a library system which we call a lib system, which actually allows the controlled electronic access to copyright material from a group of university. So this basically this library system has five layer architecture, with the bottom layer being the individual database in each library. So if you see that we have a web browser interface where the actual user comes or a student comes and it actually interacts with the library system, and then in the bottom neck layer there are different logins available, like library system login, like there are different forms and query manager and print manager. And then in the third layer you can see that there are different kind of searches available, like you want to do some kind of distributed search, or you want to get some document retrieval, or there are some rights manager, or you want to perform some accounting functions. And then against the specific request there is each library indexes available, which will be ultimately helpful to search it into the different databases ranging from database 1 to database 2 to up to database n. So this is a typical example of library management system, which is actually you can say that which is actually is a layered model of a system for sharing copyright documents held in different libraries as shown in this figure. So basically in this layered model of a system So basically, a layered model of a system for sharing copyright documents held in different libraries is shown in this library system diagram, which is actually comprises of 5 architecture levels. So there are some benefits of layered architecture as well. So there are some benefits and there are some drawbacks as well. So what are the benefits? So first of all, the most big advantage of this layered architecture is it allows a replacement of entire layer so long as the interface is maintained. So redundant facilities can be provided in each layer to increase the dependability of the system as well. We can also achieve the security and availability in this layered architecture as well. It also supports the incremental software development. So after the formation of one layer, then we move into the next layer as well. So it also enhance the independence of layer to lower level. So you can say that there is no impact from changes of lower level services, only the adjacent layer will be affected. So our interface remain unchanged unless or until there is no ripple effect will be seen. Other ripple effects will be seen in the user interface as well. So there are this layered architecture is also provides a component based technology, which is a suitable technology to implement any layered with architecture. So it also provides the promotion of portability. So what does it mean, the promotion of portability? So we also discuss this portability in non-functional requirements as well. So in this promotion of portability, we can say that each layer can be an abstract machine which should be deployed independently, and it also provide enhance the flexibility as well. So now what is the how this layered architecture can enhance the flexibility, like interchangeability and reusability are enhanced due to the separation of the standard interface and its implementation as well. So where some advantages are existing, there are some also some limitations of this layered architecture as well. So what are different limitations of this layered architecture? So in practice, providing a clean separation between layer is often difficult, and high level layer may have to interact directly with the lower level layer rather than through the immediate layer below it. So performance can be also a problem of multiple levels of this layered based architecture as well. So other limitations can be like many applications cannot fit this architecture design as well. So there are also a separation of concerns issue also available. So if we see other drawbacks of this layered architecture, so any breach of layer communication में cause deadlocks, अगर हम किसी भी लेयर के दरम्यान कम्युनिकेशन में कोई भी ब्रीच हो जाए या कोई भी लेयर दो एडजेसेंट लेयर के दरम्यान कोई भी डिसकनेक्टिविटी इशू हमारे पास आ जाए, तो देर इज़ अ सिचुएशन ऑफ डेडलॉक एज वेल. सो मैनी एप्लीकेशंस कैन नॉट फिट इन दिस आर्किटेक्चर डिज़ाइन एज वेल. सो देर इज़ also issue of exception handling also existing there. So we can also say that since faults in one layer must propagate up to all its calling layers as well. So we can say that where we have some advantages, we also have some disadvantages as well. So students, now my question to you is, in what kind of cases we will be used this layered based architecture? So we normally use this layered based architecture we where we have to build new facilities on top of existing system. So like when the development is spread across several teams with each team responsibility for a layer of functionality. हम ये layered based architecture mostly utilize कब करते हैं, जब हम कोई भी न्यू फैसिलिटीज़ को किसी एग्जिस्टिंग सिस्टम के जब हम किसी भी न्यू फैसिलिटीज़ को बिल्ड करते हैं और उसको हमें एग्जिस्टिंग सिस्टम के टॉप ऑफ द रैक के ऊपर हमें बिल्ड करना हो, देन मोस्टली हम ये लेयर्ड बेस आर्किटेक्चर को यूटिलाइज करते हैं. इन अदर केसेस इसको हम कब यूटिलाइज कर सकते हैं, जो जब हमारी डेवलपमेंट टीम है वो स्प्रेड हुई हो क्रॉस सेवरल टीम्स के ऊपर, और जो हर टीम है वो हर एक स्पेसिफिक लेयर की फंक्शनैलिटी के लिए रिस्पॉन्सिबल हो. और और इसके अलावा अब हम इसको कब यूटिलाइज़ कर सकते हैं, जब हमें मल्टीपल लेवल सिक्योरिटी को अचीव करना हो, तब भी हम मोस्टली इस लेयर्ड बेस्ड आर्किटेक्चर को यूटिलाइज़ कर सकते हैं. सो वेयर वी हैव सम एडवांटेजेस एज वेल, वी आल्सो हैव सम डिसएडवांटेजेस एज वेल. So there are some also specific conditions where we can use this layered based architecture. So what are the conditions? Like when we need to build new facilities on top of existing system. It's a situation number one. And the situation number two is when we have a several teams is actually spread across the number of different functionality of different layers. It's a situation number two. And when we required a multi-level security, we normally utilize this layered architecture, so it's a situation number three. So there are different situations where we use this layered based architecture. So students, still here our discussion about hierarchical software architecture, which is layered based architecture, is comes to an end. So till here our lecture number 19 is ended.